HANAS, Hybrid Artificial and Natural Atomic Systems, is a project funded by the European Union within the FP7 program. In this video, our scientist HANAS will explain the problems HANAS is trying to solve and how. Let me start with the problem we aim to solve. Around the clock and around the world, huge amounts of data are exchanged via the internet and transmitted as electrical or optical signals in the form of bits. But unfortunately, our modern communication system is vulnerable to unwanted attacks. This can be not only very annoying, it could also mean large financial losses. In spite of massive efforts to make communication more secure using encryption, secret keys, absolute security still cannot be guaranteed. This situation must be changed, and there is a worldwide research effort to find the ultimate solution to this problem. In the 1970s and 1980s, a possible solution was proposed by US and Canadian physicists who envisioned the possibility of using the laws of quantum mechanics to make secure transmissions. The basic idea is that the secret key consists not of classical bits, but of quantum bits or qubits. Similar to bits, we need to be able to generate, transmit, and store qubits. To do that, we need new hardware. So, let's see what a qubit is and how we generate it in the first place. The most promising way of qubits being used in communication involves the properties of photons, the particles generated by any light source, such as a lamp. The problem is that a lamp generates random numbers of photons, which is not good for our purpose. Single atoms would be a better choice, but they are difficult to handle as they tend to fly around. A better choice is to rely on artificial atoms, which are made of semiconductors, the same class of material which are now in every electronic system, such as your computer, cell phone, or TV. Here I am. I'm an artificial atom or quantum dot. I am a nanostructure about 1,000 times smaller than a hair, and I consist of several thousand atoms of aluminium, gallium, and arsenic. One of my capabilities is that I'm able to generate single photons when I'm asked to do so. Generating qubits is not enough to solve our problem. During transmission, many of them get lost, and we need a way to alleviate such losses. To do so, new mechanisms have been conceived which require photons to be stored for a while. But photons travel at the speed of light, so how do you stop them and store them? Well, here's the idea. Clouds of atoms, such as rubidium, could be used to store them. And this is the core idea of our project, to bring together artificial and natural atoms. While natural atoms are all identical to each other, artificial atoms are all different. Each of them is built of many atoms, and their number and arrangement fluctuates. So, each artificial atom has its own spectrum, that is, its own language. And most of these photons cannot be stored in the rubidium clouds. But here we have a solution too. Artificial atoms are very sensitive to stress. If we gently press them, we can change their spectrum. And here we go. We match the wavelength of the emitted photons with the absorption of the rubidium cloud. The next step and final goal of HANAS will be to stop them. I hope you enjoyed this short trip through our exciting project. Our bid to create secure communication using quantum mechanics is already working for short distances. Extending it to longer distances is still a big challenge, but we and many others are working hard on this. If you want to learn more about how our artificial atoms are made and how light slowing and storage works, come back again. Bye-bye.